We're going to talk about congruent triangles. Now, congruent triangles are any two triangles that have the same angles, but are not enlargements of each other. Okay, so all the lengths are the same. The only thing that can happen is they could be reflections of each other, yeah, or they could be rotations of each other. So they don't have to be like identical. Now, what I want you to think about: look at this triangle on the bottom. Measurements are 6, 13, 15, and the angles are 59, 97, 24. Now, I want you to call up a friend, and I want to think about what is the smallest amount of information you can give your friend that would actually make them draw this triangle. Now, you could give them all the information, you give them all the sides, and you could give them all the angles. That would definitely work. But maybe we don't have to give all that. Maybe we can just reduce it to just 3 items. Like, for example, I don't have to give them all 3 of the angles, because if I give them 2 of the angles, that's actually locks in the third. And they could do 180, take away the sum of both those angles to the third angle. So think about what's the smallest amount of information you need to give. And then pause the video and think. Okay, now you might think, well, I'll just give them the 3 angles. Now the 3 angles wouldn't work. Because if I give you any 3 angles, you don't know how big that triangle is going to be. So this could be similar. Now what can work is any 2 angles and a side. And normally call that angle, side, angle. And we say it in the order you're either going clockwise or you're going anti-clockwise. Okay. Now this locks it in because if you've got 2 angles, you've got a third angle. Yeah, because you take away from 180. And then we've got one side that locks it in the sides of that shape. Okay. And any variation of this would work with any 2 angles and one side. So sometimes they're called angle, angle, side, or side, angle, angle. The other thing we could do is sort of like the opposite of angle, side, angle, which is side, angle, side. Okay? So any side, angle, and then side. So it's got to be in order. That locks it in as well. Okay? The last one we need to deal with is side, side, side. So if you give them any 3 sides, there, that locks it in. You can't, the angles have to suit. And you need to know how to draw these as well. That's for a different lesson. Okay. The only extra one is what about if it's a right angle triangle? Okay, so if you've got a right angle triangle, okay, we call it right angle. Yeah, the hypotenuse and any other angle, okay, will work. This is in addition to the previous ones as well. And if you think back to trigonometry, if I've got a hypotenuse and a right angle and an angle, yeah, then I can use Pythagoras or anything really just to work out the other 2 sides. Okay. Now the other one you might see, which is that angle side side. Okay, that may not be congruent. Yeah. Now if I show you this animation here, both those 2 triangles of ACB and ADB, okay, they've got the same angle, which is shown here. Okay, they've got this side here, which is the same, and these 2 lengths are the same length. They're just facing the opposite way. So angle side side is not congruent. And that's the only one you need to remember. And it spells the word as, which is obviously not a nice word, so it's a way to remember it doesn't work. Okay. So have a look at these and think, which rules are they? Now that one there is, if you go clockwise, it goes angle side angle. This one here is angle side angle. Good. That one there is angle angle side and angle side, but we don't like angle angle side. It will true in your working exam for angle angle side. We actually like to call it angle side angle. This one here, you've got all 3 of the sides, so it's going to be side side side. That one there, it's a right angle triangle. Okay? So it's right angle side hypotenuse. Right angle hypotenuse side. Okay, you've got some triangles here in front of you. Okay, I just want you to know, given information, so if they're sides of the angles, can you decide whether these are congruent or not? Okay, pause the video. So this one here, I've got 1 side, 2 sides, 3 sides. Would side, side, side make it congruent? Yes, that would. Next one, I've got information of an angle, an angle, an angle. That's not actually congruent because they could be enlargements of each other. I've got angle, side, angle. Yeah, that is a rule of congruency. Now, angle, angle, side. Yeah, that's actually the same as the previous one because I can work out this angle here, can't I? We tend to make it angle, side, angle. This one here, I've got angle, side, side. Now, angle, side, side is not a rule because that's the one that just like I get 2 possible versions. So I'm putting across. This is angle, sorry, side, angle, side, which is a rule. Okay. Now I've got right angle, I've got my hypotenuse on the side, so right angle, hypotenuse, side. Now, right angle, I don't have a hypotenuse, so you might think, well, maybe this isn't congruent. But just because it's a right angle doesn't mean I can't use the other rules of congruency. So I actually have an angle, and I've got a side, and I've got an angle. So it's actually angle, side, angle. Good. Now, this one here, sometimes you're asked to prove, are these congruent? Okay? And you've got to be clear with like you're working out. It's good to do bullet points, really. So we need to either prove, so we know that AE equals AC. And it's given in the question, so I'm just going to write given. Yeah. I know that BC is going to equal CD. And again, that's in the question. So that's given. Do I know anything else is the same? Now, I actually know the angle ACB must equal the angle DCE because they are vertically opposite angles. That's it. Now, do I have enough information here? So I've got side angle side, yeah? So then I'm going to put a side angle side so it's congruent. So you get a question where you prove these two triangles are congruent. Let's work it through. So I know ABC is the same as CDE. I'm going to put it because it's given. You could put because they're 90 degrees as well. That's also fine. I also know that BCA and DCE are the same. And again, that's because it's given. And actually, I know that BC actually equals CD. Again, because it's given. So I've got angle, side, angle. And you've got right angle, side, angle. So this is also congruent. Now, just good questions. What I want you to do is I want you to pair them up. Okay? But state the reasons if they're congruent or if they are not congruent. Pause the video if you have to. Here's your answers. Okay, so we've got to prove that the triangle ABC is congruent to the triangle CDA. Okay. Now I know that BC line here has to equal AD. I'm going to say it's given. Now I don't want to say it's a parallelogram and parallelogram has opposite sides just because the question hasn't told me a parallelogram. It is and it has to be, but no one's told me that. And I also know that BCA and CAD have to also be the same. And that's because they're alternate angles. These are alternate angles. And so I think I need an extra thing here. Now, it's very hard to keep going back to the rules of parallelograms, but the angle AC is actually shared by both triangles. So I'm actually going to say AC equals AC. I'm going to call it a shared side. Okay. So what I've now got, I've got a side, yeah, and I've got an angle, and I've got a side. So I'm going to say side, angle, side. So it is congruent. And you need all three of these for these to make sense. Okay. There you go. Right, next one. I need to find out ADB is congruent to CDB. So left-hand side triangle is the same as right-hand side triangle. So then I'm actually going to put BC has got to equal to BA. I'm going to say it's given. It's given in question. And I'm also going to write CD equal to AD. That's also given in the question. Okay. Now I need one more thing to say that it is true. Now the third thing that I'm going to have to do is look side BD. So BD has got to equal to BD. I'm going to call that shared. Now I've got one side the same, two sides the same, three sides. So I've got side, so it's congruent. Now there are other things I can do. Yeah. Now it doesn't state in the question this is a rhombus, but because it's all sides are the same, it is a rhombus. But if I wanted to do it, I need to have to write all sides are the same for the quadrilateral, as it's a rhombus, yeah? and then you can use the properties of a rhombus, yeah? And the properties of a rhombus would be that the angle BAD is the same as BCD. And you could use that then to get angle side angle side. Right? Right. So now you've got this one. ABCD is a parallelogram. It tells you the information now. So it proves that angle ABC are congruent to ACD. Now, very similar to the question we did a few examples ago, but I want you doing it using the side. I want you to use it doing the side and the angle side angle. So all three different ways you can do. Okay, right. Now doing the side, I'd say AC is shared. I'd say AD is the same length as BC because it's a parallelogram and opposite sides are the same length. I'd also write AB is the same length as DC because opposite sides are the same length. Okay, so it's congruent by side. Right. Side angle side. Okay, you could do two sides like you did previously, any two sides would be the same. Now the angle, I'd say DAC and BCA are alternate to each other. Okay. There are other things you could do. You could say ADC and ABC are opposite angles in a parallelogram, which have to be equal. Now, using angle side angle, you can just use any of previous ones just to prove that any two angles are the same, or any on one side is the same. Okay, so I need to prove that MYR is congruent to AYR. Right, so I would say that MR equals RA is given. I'll then say that MRY has got to equal YRA. And I'd say because MRY is 90 degrees, and I'm going to say MRA is a straight line. And because it's a straight line, this must also be 90. But make sure that you put that in your response. You just don't just assume that it is 90. Okay? And let's do the easy one, which I'll be honest, I always forget. RY has got to equal RY because they're shared. So that means that I've got angle side angle. Yep. Which means it's congruent. Okay, so diagram shows triangle ABC. MNB is a parallelogram, so LMNB is a parallelogram. M is the midpoint. Now this midpoint shows that AM is the same length as MC. Okay. N is the midpoint of BC. Prove that ALM and the triangle MNC are congruent. You must show proof. So this is quite a confusing thing. So I'm going to draw over it. So ALM, yeah, is congruent to MNC. Let's see what we can work out from this. So I know that actually AM has to equal MC, right? And as M is a midpoint. Let's see if we can work out anything else really from this. Well, I know that LM must equal NC, and if you think about this, LM, okay, has to equal BN, as opposite sides of a parallelogram are the same. And I also know that BN must equal NC, as N is a midpoint. Okay. So I've got two sides that are the same. Now, I could actually prove that MN, by the same logic, equals AL, because I know that MN has to equal LB, as opposite sides of a parallelogram are the same. And I also know that BL has got to equal LA, as L is the midpoint. So now I've actually got three sides of the same. So I've got side, and you actually have to write side. So it's congruent. Now, I'd imagine there's other ways you could prove this. Let's see what it says there. And there's all your other versions. Okay, so ABC is an equilateral triangle. D lies on BC. Okay, it doesn't say it's in midpoint. AD is perpendicular to BC. Okay, now we have to prove that they are congruent. Okay. Now, if you've got a question on this and you do get stuck, just prove as much as you can do that it's the same, and then see what we have at the end. So let's see what I do know. Because it's equilateral, I actually know that ACD must equal to ABD, and it's equilateral. Equal LATE. And I'm actually going to put in brackets it's 60 degrees, because it must be because it's 60 degrees. The other thing I can prove is ADC must be equal to ADB, right, and it's because as AD is perpendicular. Just given in a question, you could say given. Which means that it's 90 degrees. And there are other things I can prove actually. Yeah, so think about my sides. I actually know that AC must equal to AB, as it's an equilateral triangle. Triangle. I know that AD has got to equal to AD actually, because they're the same. Shared, I'm going to say. So I've got options now really, because I've proved that two sides are the same and two angles are the same. Yeah. Because I've got two angles the same, I know that the third angle must also be the same, just for the fact of it. So I've actually got angle side angle here. That means that they're the same. Now, so hence prove that BD is half of AB. Now we know that BD has got to equal DC, and the reason is because it's congruent, as we proved previously. And because it's an equilateral triangle, I know that BC must equal AB. So I'm going to put thus BD must be half of AB. Right, last one I'm going to do here, because I've done quite a few examples. Right, AOC and BOD are diameters of the circle, so they're definitely the same length. And if O is the centre, we know that BO and OC and OAD and OA are all radii. Prove that ABD. I'm actually going to draw this in. So ABD and ACD are congruent. So I'm going to see if anything's the same. But I actually know that AD is the same as AD because it's shared. What can I do? I know that CA is the same as BD, as they are diameters. Now I know the angle BAD is going to equal to ADC, as they're both 90 degrees. Okay, because that's one of your circle theorems, that angle in the diameter. So here I've got a right angle, and I've got my hypotenuse, and I've got my side, which means that they are congruent. And again, there might be other ways we can do it, but that's what I'm going for. Is that your marks in? Right, here's the questions I want you to do. Wait, prove them, show each of your stage clearly. These from Colbert Maths. And here's your answers for the first couple. Here's your answers for the next couple. Right, I hope you enjoyed that lesson. Some harder ones that I'm not going to go through.